Hi everyone and welcome to this video. It's been a while since I did something on macOS, but in this video you'll definitely have your portion of that, as I will explain and show you how to run macOS in a virtual machine on top of a silicon-based Apple Mac by using UTM. When talking about running a VM on a Mac, most of the times people assume you're talking about running Windows, but it's perfectly possible to run macOS virtually as well. This will allow you to run a different separate macOS instance on different versions if you like, independently from the natively installed macOS version on your machine. This allows you for some experimenting with different versions or playing around without the risk of breaking your main macOS instance. In this video, I'll explain you step by step how to get this going when you're having a silicon-based Mac. And instead, if you would be using a Mac which is still Intel-based, don't worry, as I do have a working solution for that as well, which I will cover in my next video. So make sure to subscribe if you're looking for this. Before we look into how to do this in practice, I would first like to provide some background information on using UTM to virtualize macOS and explain some of its limitations as well. Feel free to skip to the next chapter to dive in right away, of course. UTM is a free open source piece of software that allows you to run virtual machines. It was specifically built for Mac and allows you to run VMs either on the same CPU architecture or by emulating another CPU architecture than the hardware you have. Now, of course, the concept of running virtual machines is definitely not new. And also running macOS in a virtual machine isn't something that wasn't possible before. And there are also several alternatives for UTM out there on the market, although when using an Apple Silicon-based machine, so the ones which have an M1, M2, M3 chip and so on, your choice might be limited. If you're following my channel for a bit longer, you might also know that I already did some videos on UTM in the past, where for example I explain how to run Windows 98 on an M1 based machine. Originally, UTM was using QEMU in the background for its virtualization and emulation, which is one of the most popular ways to do it. Over time, Apple introduced its own extensions for virtualization natively in the operating system's API. These are called the hypervisor.framework and virtualization.framework. The advantage of these is that they require less overhead and can take advantage of things like hardware acceleration and even Rosetta 2 emulation. The support for the virtualization.framework was added by Apple to macOS 11, also called Big Sur. This framework allows virtualizing Linux guests and, that's what we are interested in for this video, also supports macOS guests. This framework got implemented in UTM version 3.0, and the requirements to use it for virtualizing macOS is that you are on an ARM64-based machine, so a silicon-based Mac, and that you are on macOS 12 Monterey or later, as you can see. To be clear, as I mentioned in the beginning as well, this all here doesn't mean that it's not possible to run macOS in a VM on an Intel-based machine, just not with UTM and not fully using the Apple integration. But for this video, I'll be using my M1-based MacBook Air. I'm running the currently latest version of macOS, which is Sonoma or version 14 at the time of making this video. So the requirements to continue with UTM are met. The first thing we need to do is to install UTM. Simply, we can go to UTM's website and click on Download. I'll share the link in the description for this as well. Once UTM is downloaded, we can go to the Downloads folder and double-click on the utm.dmg file, and all we have to do is drag the utm.app to the Applications folder. That's it. Now we can start UTM from that same application folder and just confirm that we are okay to open it. Now that we have UTM installed, the next step is to create a new virtual machine and get macOS installed on it. To do so, in UTM, click on Create a new virtual machine. Select the first option, to virtualize, as we want to use the same CPU architecture as our hardware has and do not want to emulate another architecture. Next, we need to select which operating system we want to install on the VM. Here we need, obviously, to choose for macOS 12+. In this step, you can choose a specific IPSW file. Originally, IPSW stands for iPhone software, but Apple has recently started to also distribute macOS in this file format. As you can read here on this step, UTM can download the latest compatible macOS version automatically, which is done if you do not specify an IPSW file yourself. Instead, if you like, for example, to run a specific macOS version, newer or older than that latest one, You can also download and provide IPSW files yourself from websites like ipsw.me or from Mr. Macintosh. I'll still cover that near the end of the video, but for now, let's first start by leaving this empty and let UTM download the image for us. In the next screens, we need to choose how much memory we want to give to this virtual machine and how large the disk image should be. Let's increase that memory a bit to 8 GB, as lower tends to really slow things down. The last step before UTM will download the files is a summary. Here we have an extra confirmation of what I explained in the beginning. UTM will make use of Apple's virtualization API rather than using QEMU in the background. Now we can click Save to continue with the VM creation. UTM will then automatically start to download that latest IPSW file from Apple. In my case, the download took roughly 5 minutes. Then once the download completes, you can see the new virtual machine in the list in UTM with an Apple logo. Now, to actually perform the installation, which is fully automated as well, all we need to do is to start the virtual machine and confirm that we want to start that installation. We can follow the progress of the installation on top of the virtual machines window here. In my case, this again took roughly 5 minutes, and if all goes well, you should end up with the initial setup wizard of macOS. Here we simply need to answer the questions we get regarding our region, language, keyboard, and user account. This is exactly the same as if you would perform a fresh installation of macOS on real hardware. Eventually, you should end up on the desktop of your newly created macOS virtual machine. Let's take a look at About This Mac first. As you can see, it's running the latest version of macOS, 14.5. At least this was the case at the time I created this video. And in general, everything looks pretty good. From here on, you can go on and play around with the virtual machine. You can install applications, change system settings, reboot the virtual machine, network connectivity should be working out of the box, and you can do whatever you can just like you do with natively installed macOS. If desired, you can also even clone the virtual machine for easy recovery if you want to try something out that could potentially break the operating system or render the machine unbootable. So far, everything went pretty easy and straightforward, and at this point, you might be wondering how macOS in a virtual machine actually does in terms of performance. Running an OS in a VM obviously comes with some performance penalty in comparison with running it natively. So let's test how big this impact is by running some benchmarks, both on the virtual macOS system, and then we'll compare it with the real hardware performance. Let's start by CPU performance. For this, we can use the CPU benchmark in Geekbench 5 and 6. First up is the older Geekbench 5. Our virtual machine seems to get a score of 1686 single-core and 5687 multi-core. Straight up, I can tell you that this is great performance already and is better than, for example, what my MacBook Pro 2019 can do without virtualization. Compared with the same test on the host itself, so natively installed, directly on the hardware, we can see that there is a slight difference, especially in the multi-core performance, but I guess that's mainly because some resources are reserved for the host itself. Let's repeat the same test with Geekbench 6 now. Here we seem to get 2307 for single core and 6831 for multi-core. Again, this is better than that same MacBook Pro 2019, and compared with the M1 MacBook Air natively, we see a similar difference as with the previous test. Let's have a look at this performance now, for which we can use AGA system test. Not bad, but as you can see, quite a bit less than what we get natively on this machine. So far, the test results are pretty good, especially CPU-wise. There is almost no penalty, and also the disk performance is not a deal breaker for sure. Unfortunately, and this is probably the biggest negative side here, it's not possible to use any of the compute engines in the virtual machine. This means that things like video editing or other tasks that rely on having a GPU or require OpenCL or Metal support, 3D acceleration, most likely either won't work or will perform poorly. But separate from that limitation, as you can see in the results and can also notice when I'm navigating around in the VM, performance is actually very good. Despite a small penalty here and there due to the overhead of the virtualization, everything still feels very snappy and fluent. If you would run the virtual machine maximized on the screen, you would need to do your best to notice that it's not running directly on real hardware, to be honest. One small extra thing I want to cover here is about the ability to share files between the host and guest machines. When you're playing around with virtual machines, sooner than later you'll end up in the situation where you want to copy files back and forth. Fortunately, UTM has the ability to create shared folders, which allows you to easily transfer files. To use this feature, we'll first need to shut down our virtual machine. Once it has been shut down, in the UTM main window, right-click on the VM and choose Edit. Then in the VM settings, navigate to the sharing option on the left side. Scroll down in that window and add a folder to be shared with the virtual machine. To test this feature, I'll just create a test share folder here on my desktop. Then we can restart the virtual machine again. And we can immediately see a new location, My Shared Files, which lists the folder that we have selected on the host machine. Any files that are in there or get moved copied in there will be available from both the guest and host machines, as you can see. So far for this video, we've let UTM download the latest macOS version available from Apple for us. This is an easy and safe choice, but maybe it doesn't completely suit your needs. So, in case you would like to run a specific version of macOS, you will need to search for an IPSW file that contains that version or specifics that you're looking for. There are several sources for these files available online, and I believe that the most popular ones are ipsw.me, which lists a large list of different macOS versions and variations on that, and another known source is Mr. Macintosh's IPSW firmware restore files database. The difference is that these versions here should be the official Apple-based versions. To demonstrate, let me download an IPSW file of the latest macOS 12 version, also known as Monterey. Once the file is downloaded, the process to use any of these files is very similar as what we've did before. The only difference here is that when we're creating that new virtual machine, we need to provide our downloaded IPSW file to UTM. The rest of the process is exactly the same. Once the virtual machine has been created, you can just start it as well, and it will trigger the installation of macOS from that specific IPSW file which we provided. After a bit of patience, the virtual machine will boot into the newly installed macOS version which we've downloaded. And as you can see, almost without any effort, we now have a second virtual machine running macOS 12 in this case. That was it for this video. I hope you have liked this and it can help you. A thumbs up is always appreciated. Subscribe to my channel if you're interested in more of these kind of videos, and let me know how this works out for you or if you have any questions in the comments. Thanks again and hope to see you back here soon.